So let's talk about rounding based on the number of significant figures that we want to work with here. So some explanation up here, and really it should look better in practice, but just to give you some terminology. So we're going to locate the rounding digit, and we'll do this by counting to the left. So let's do this for our first case here. So we have this 21,837, but we want to round this to two significant figures. So if I write 21,837, and that first step tells me to locate the rounding digit to which you're rounding by counting to the left. So I can see here's a significant figure, here's a significant figure, so that makes 2. So this is going to be my rounding digit. So what I'm going to do is just highlight my rounding digit there. The test digit is the number that's exactly to the right of it. So this 8 right here is the test digit. And actually, let me label these since this is new terminology. So this is what we're rounding. This is what we use to test whether or not we're rounding up or down. So it's the same rule as when we rounded using decimal places. If it's 5 or greater, we increase, so we round up. If it is 4 or smaller, then we round down, which means we keep the rounding digit the same. So because that's an 8, this is telling me to round up. So what that's going to do is I'll have the 2, and then where I had a 1, I'm rounding up to a 2, and then the rest turns into trailing zeros. So what this does is it gives me two significant figures because I have my two non-zero numbers, and then just a bunch of zeros. If for some reason I end up with a bunch of zeros and I need to make more significant figures, then the overbar comes in. Like if I had an overbar here, I would have 3 significant figures, 4, 5. So sometimes you'll need to use the overbar so that you can get to the correct number of significant figures if zeros come through. But in this case, we have our 2 significant figures, and then the zeros at the end work out because those don't count as significant figures. Okay, so with that, we're going to use the same number, 21,837, but then what I want to do is have 3 significant figures. So counting from the left, I'm going to have 1, 2, 3. So that makes 8 my rounding digit, which means I need to test it with the 3. The 3 is going to tell me whether I round up or down, which because 3 is small, we're going to round down, so we're going to keep the 8. So that means we're going to have 21,000. 8 stays the same because we're rounding down, and then just zeros. And that gives us 3 significant figures. And then 21,837, and we want 4 significant figures. So we're going to go from the left, 1, 2, 3, 4. And with that, 3 is our rounding digit. And then to test it, whether we round up or down, I'm looking at the 7. And because 7's large, that means we're rounding up. So I'm going to have the 21,800, and that rounding digit is going to become a 4, and then we'll have a 0. And that'll give me 4 significant figures. Okay, so what happens when we have a decimal? So 4.2782, and I want to have 2 significant figures. So with this, again, counting from the left, I'm going to go 1, 2. That's going to make the 2 my rounding digit. Now I'm just going to test it with the 7 of whether I round up or down, and because 7's large, we're rounding up. So that'll give me 4 point, and then 2 rounds up to a 3. And what changes here is that we're up above, we replaced values with 0. That helped me keep my place values, like 22,000, 21,000. Like I always had these things in the tens of thousands, which is exactly what we want. That changes here because what happens if I include zeros there? If I put 3 zeros there, remember any 0 to the right of the decimal place is significant. So this right here has 5 significant figures, which is way too many. So what we need to actually do to make sure it's only 2 is we don't include the zeros here. We don't need the zeros there because 4.3, I would actually read that the same out loud. Like, this is 4.3. This is also 4.3. But the zeros add a level of accuracy to it, so we need to be careful of that. So if I want only 2 significant figures, then I just end like that. So 4.3, don't include the zeros at the end. For 3 significant figures with this one, so counting from the left, 1, 2, 3, so 7 is my rounding digit. And so 8 is going to be my tester, and we're going to round up because 8 is large. So that is going to give me 4.2. 7 rounds up to 8. And then again, we don't want to include the zeros there because that would add more sig figs. And right now we're at the perfect number of 3 of them. All right, one more here where we want to round to 4 significant figures. So 4.2782. And counting from the left, we have 1, 2, 3, 4. So that's going to make 8 our rounding digit. And then to test whether we round up or down, I'm looking at the 2, which 2 tells me to round down. So we're keeping the 8 as it is. So this will be a 4.278. So that's how we can round using our significant figures, where they specify a certain number, and then just the difference between when you have these big whole numbers versus decimals involved, and just how you use the zeros differently, where trailing zeros don't count as significant figures, but zeros that are to the right of the decimal place do count. And then let's go ahead onto the accuracy when we're multiplying and dividing. So we'll use a calculator to help us with these, and then just write on your paper as many decimals as you can. So without reading up above, let's just say we carry out this multiplication. And I'm just going to go out to, let's say, 4 decimal places. So 93.86 or 83. 66 is what I would get for the calculator for that one. And then with this division in the calculator, I'd be getting 20.07317. So calculations from the calculator, and then just grab a bunch of decimal places as you can. Now, when we want to keep accuracy with these, what we're going to do is use the significant figures of the original numbers. So let's just look at counting the number of significant figures. And we want to look at these separately. So the 3.86, well, that's just 3 non-zero numbers. So this has 3 significant figures. 24.31, that has 4 significant figures because all 4 digits are non-zero. Now what we do is we use the smaller of those 2 numbers. So where we have 3 significant figures versus 4 significant figures, the idea is that 4 has more accuracy to it and 3 has less. So when we round the result of that computation, we're going to assume we have the least accurate number of significant figures. So what I'm going to do is use that value of 3 significant figures for the rounding of the number that we found. So I'm going to take that number and round to 3 significant figures. So with that, I'm going to go 1, 2, 3. So 8 becomes my rounding digit. To see if I round up or down, I'm looking at that value of 3, which tells me to round down. So the rounding of this will be 93 point, and then we keep the 8, and that would be my result of multiplying those 2 numbers and then using accuracy to round. In terms of using accuracy to round, we look at the significant figures of the 2 original numbers, or as many original numbers as you have that are multiplying or dividing together, and use the smallest of significant figures of those. So because that 3.86 has the least significant figures, that's the value we use for rounding. So over here, let's look at the numbers we started with. So 82.3, that has 3 significant figures. 4.1 has 2 significant figures. So for rounding my value, I want to use the smallest of those 2, which is the idea of 2 significant figures. So that's what I'm going to use to round my number here. So 2 significant figures here. So I'm going to go 1, 2. So that makes 0 my rounding digit. And then to test whether I round up or down, I'm using that 0 right there, which tells me to round down. So when I round this, that means I'm just ending up with 20. However, notice that that number actually only has 1 significant figure, which isn't enough. We have enough accuracy here to get to 2. So what I'm going to do is I'm going to put an overbar to say we looked at that 0, we rounded with it, we know we have accuracy to that 0 right there, and now this has 2 significant figures. So that's rounding correctly. Sometimes another notation that comes up here that I believe we'll just focus on using the overbar, but I want to show you is sometimes just a decimal place is included there to show we have, like, those trailing zeros are accurate until we have that decimal. This notation also has 2 significant figures. It's like having an overbar on the last 0 from where you're trailing from. So with this has 2 significant figures. Just notice you wouldn't want to write 20.0 because then you have 3 significant figures, which is too far. So we wouldn't want a 0 after, but sometimes a decimal at the end that can imply the same thing that 2 with an overbar of 0 there does the same.